go. All right, here we go. Okay, ladies and gentlemen, here we go. We are going for the unit circle. So, to begin, we're going to talk about the unit circle, okay? Okay, so here's what I want you to do. I want you to draw yourself a coordinate plane, okay? And on this coordinate plane, of course, we have the x-axis and we have the y-axis. So far, so good. Stuff we already know about, right? And inside that coordinate plane, I want you to draw yourself a circle. Do the best you can. Oh, mine's actually not bad. I've drawn worse. Okay. So, on this circle, every single circle needs a radius. So we're going to give our circle a radius of 1 unit. All right? We have a circle with a radius of 1 unit. If that's the case, then what does this point right here have to be all the way over to the right? What point does that have to be? What is a coordinate, right? We're in the coordinate plane, so give me the coordinate. 1, 0, right? The radius is 1 unit, okay? So what does this point have to be over here if my radius is 1 unit? 0, 1. Good. What about this point over here? Negative 1, 0. What about this point down here? 0, negative 1. Good. So far, so good? All right. Every single point in the coordinate plane has an xy coordinate. And there are some key points here. And these key points are going to lie on this circle. But in general, okay, if I call this point P, then point P is associated with it an x and a y, meaning that I would go over to the right so far for the x direction and up from the x-axis and the y part to give me an x, y. You can see there's already 4 points on that coordinate plane. All right, so now, we also talked about the other day the idea of this circle, that there is a distance that we've covered that's been swept out by this thing called s, which we call arc length. Right? And there's this angle inside of here swept out that we call theta, assuming that this angle is drawn in standard position. All right? So far about the unit circle, here is what we can say, here's what we know. Okay? The unit circle is a circle with a radius equal to 1 unit. Right? We also can say that the center is at the origin. And we can also make this connection between this arc length and this theta here, right? What is the connection between arc length, theta, and the radius? What's the arc length formula we learned in section 4.1? What is it?
The arc equals theta times radius.
Yeah. S is equal to r theta. That distance that we have is equal to r theta. So that distance being the arc that we've swept out is equal to the radius times theta. Now in this case, for the unit circle, what is the radius? 1. So that means that s is equal to 1 times theta. Well, that just means that s is equal to theta. Now when we're dealing with the unit circle, okay, I change theta to a t. So now s is equal to t. This is a very important relationship. They change the theta to a t. It's the same thing, yep. So what this says is that the arc length is equal to the radian measure of our central angle. The arc length is equal to the radian measure of our central angle because our radius is 1. There are 6 trig functions that we're going to deal with for the rest of our life, and mostly in this class. All right, I'm going to give them to you in a certain order. Hopefully you see a pattern that develops here. Okay, the first one is called sine. This is a trig function. Okay. Oh, you guys are excited. I love it. Okay, now there's an abbreviation. What? What's wrong? Value. Unit circle value. V-A-L-U-E. Value.
Isn't sine the inverse of regular sine?
No. Don't get yourself confused. Okay. Let's talk about this. There's 6 of them. We got sine. The abbreviation for sine is S-I-N. Please do not say the sin of something. Okay? It's not the sin of something. It's the sine of something, okay? In this case, the sine of our angle t for the unit circle is going to be the y value. We are stoked, the y value. Sine of t is our y value, okay? Sine of t is our y value. Here's the next one. The cosine. The abbreviation is COS. Please do not say cos. Okay? Please do not say cos. So cosine of t, the cosine of t is equal to x. All right, isn't that nice? We're getting there. We're getting there. Okay? One thing at a time. Yeah. The next one is tangent. Okay, now let's see what you do remember. What is the abbreviation for tangent? TAN. You can actually say tan of something. That's actually cool. So the tangent of t. Now, who remembers the ratio of tangent? What is it? Does anyone remember what it is? Yeah.
Adjacent over.
Yeah. In terms of the other trig functions, though? No. Sine over cosine. Very good. So the sine of, or the tangent of t is equal to the sine of t divided by the cosine of t. Now, in this case, the sine of t is just the value of y, and the cosine of t is the value of x. So this only works provided that x is not equal to 0. All right? So the tangent of t is the ratio of y to x in the unit circle. Remember, we're relating all of these trig functions back to the unit circle. Okay? All right, now there's 3 others. Remember what they are? Name one of them. Good, cotangent. We'll do that one next. Okay, cotangent. What's the abbreviation for cotangent? COT. Please do not say cot of anything. Okay. So the cotangent of t is equal to x divided by y as long as y does not equal 0. And why can't y equal 0 in this case? Because you can't divide by 0. Very good. There's 2 others. You know what they are? Secant. All right. Secant. Very good. Secant. The abbreviation for secant is SEC. Please do not say sec or anything. So the secant of t, in this case, is going to be 1 over x, provided that x is not equal to 0. And last but not least, we have cosecant. And the abbreviation is CSC. Please do not say cosec. Okay. And the cosecant of t in this case is going to be 1 divided by y, provided that y is not equal to 0. All right, ladies and gentlemen, I gave these to you in a certain order. Hopefully you see some kind of a pattern or a relationship between the top 3 and the bottom 3. Does anybody notice any relationship whatsoever? They are reciprocals. So there is a reciprocal relationship between all 6 of our trig functions, okay? So let me put this into some context for you. So right below this, draw yourself a circle, unit circle. Okay, give yourself a point P somewhere over here in quadrant 3. This is going to be my T. All right? And I'm going to give you some coordinates for point P. Okay, P is going to be negative 3/5, comma, negative 4/5. All right? So here's some point P on a unit circle, or on a circle. No, it's not. It's right below it. Okay? So this is an x value, and this is a y value, right? T is our angle, right? T is our angle. Our point is right here, negative 3/5, comma, negative 4/5. That's our point. Okay. Now we can begin to describe these values in terms of our trig functions. So I can describe that. I can say that the sine of t, because the sine of my angle t is a defined value, and that's going to be the x value or the y value? Well, the sine of t is defined to deal with y values. So the sine of t has to be negative 4/5. What does the cosine of t have to be? Negative 3/5. So there is some point out there in the coordinate plane. That's on the unit circle, and that point is at negative 1/2 comma rad 3 over 2. So what quadrant does that put us in right away? Very good, quadrant 2. So the first thing we're going to do is we're going to draw a picture. All right? Here's the picture that we're going to draw. We are somewhere over here in quadrant 2. Okay? There's my angle T. This point is negative 1/2 comma root 3 over 2. And that's the point corresponding to P. What we want to do is define all 6 trig functions at T, given that point right there in quadrant 2. So we have 6 things that we need to find, and it seems like a whole lot, but really, once you find 2 of these things, you know all the rest of them. So here's how I want you to write these out every single time you have to do these problems. The first one you're going to do is do the sine of T. To the right of that, you're going to do cosine of T. To the right of that, you're going to do tangent of T. So you're going to find sine, cosine, tangent. Then below tangent, you're going to write down cotangent of T. Below cosine of T, you're going to write down secant of T. And below sine, you're going to write down cosecant of T. So the second thing that we do is we set up all of our trig functions in that order every single time. Sine, cosine, tangent on the top in that order. On the bottom, cotangent, secant, cosecant going backwards. The reason we do that is because now each of these are set up as reciprocals when you look vertical. So as an example, the sine is the reciprocal of the cosecant. The cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. Okay? Now remember, according to our definitions, this is an x, this is a y. So x comes before y in the alphabet, right? Okay? And cosine starts with a C, and sine starts with an S, and C comes before S in the alphabet, right? So that means that this one, you can relate that, x stands for cosine, y stands for sine. So I have all the information I need. How can I define now the sine of T? What's the value for the sine of T? Y, right. In this case, what's the y value? Very good. So this would be root 3 over 2. What would be the cosine of T? Negative 1/2. Very good. So now that I have these two, I can automatically get the two below it, right? So let's start with the easy one. Secant. What's the reciprocal of negative 1/2? Negative 2. Very good. Now let's talk about cosecant. What's the reciprocal of cosecant? Well, the reciprocal of sine. We have rad 3 over 2. Take that, flip it over. So that'd be 2 over rad 3. And then we'll, yep. Good, very good. So you have 2 rad 3 over 3. Awesome. Now tangent, remember, is sine over cosine, right? So the sine value is root 3 over 2, all divided by negative 1/2. So it's just fraction over fraction, so I have root 3 over 2 times a negative 2 over 1, which gives me a negative root 3. You with me, guys? Everybody still with me? Why do I have a negative 2? Where? For secant? The reciprocal of negative 1/2 is negative 2.
The one you just did. What's the one you just did? Cotangent?
No, I just did tangent. Okay? Yeah? Okay, hold on. We have all 6 of our trig functions based off of our point P in the coordinate plane relating back to T. What questions do you have? For this one, what's different here? I have not given you a point, have I? But I have given you something very, very useful, and you do know that this is on the unit circle, right? So therefore, you know that this is a 1. Okay, the unit circle has a radius of 1. Now, pi over 4. What angle does pi over 4 represent? 45 degrees in terms of degrees, right? So if you have a 45-degree triangle, okay, and there was a point over here that you were trying to get to, you would need this side and you would need this side. And you know that the hypotenuse is 1. What are the lengths of the two sides? We did this one at the very beginning of class. In fact, it's still on the board. And it's also in your notes already. Very good. Root 2 over 2, and this one has to be root 2 over 2. So that means that the point that corresponds to a 45-degree angle with a radius of 1 has to be rad 2 over 2 and rad 2 over 2. All right, now that you know that information, can you tell me what will the sine of pi over 4 have to be then? Rad 2 over 2. Very good. How about the cosine of pi over 4? Rad 2 over 2. Good. How about the tangent of pi over 4? 2 over 2, which is how much? 1. Very good. Doesn't it make sense since the sine and cosine are equal? When you take their ratio, you'd get 1, right? Because they're not 0. Okay, now let's take the reciprocals. What's the reciprocal of 1? What's the reciprocal of 1? 1. You're thinking of opposite. The opposite of 1 is negative 1. The reciprocal of 1 is just 1. Okay, now, root 2 over 2. Let's invert that. Yeah, very good. So, these things? Which is how much? Yeah, just rad 2. Okay? Okay, I'll show you how to do this one. So take 2 over rad 2. We will multiply top and bottom by rad 2 over 2. Notice we get 2 rad 2 over 2. The 2's cancel, which just gives us a rad 2. Those would be equal. That's how we got that one as well. So the cosecant of pi over 4 is root 2. Secant pi over 4, root 2. Cotangent pi over 4, 1. And we have all the other ones. So how do you know what the point is associated with pi over 6? How do you figure this out? Like, what is it that you do? What's the thought process? Yeah, it forms a special right triangle, right? This is a 30-degree angle, and your hypotenuse is 1. Well, at the beginning of class, we figured out that then this side has to be root 3 over 2, and this side has to be a half. Oops, a half right there. So that means that the point associated with a 30-degree angle has to be root 3 over 2, comma 1 half. So you don't have to have that point there in order to figure it out. Root 3 over 2, comma 1 half. You just have to know that the radius is 1. And if it's on the unit circle, then it's guaranteed to be 1 by definition, right? So that means that you should have got this. For sine of pi over 6, you should have got a half. Cosine of pi over 6 should have been root 3 over 2. And the tangent of pi over 6 should be rad 3 over 3. Once you have all of these, you take the reciprocal. So the cosecant of pi over 6 is just 2. Secant of pi over 6, I got 2 rad 3 over 3. And then the cotangent of pi over 6, I just got a positive rad 3. Okay, remember that, right? Whenever you have x and y, x is cosine, y is sine. That should help you out. And there are 2 of these that are going to be undefined. See if you can identify them in your groups. Okay. 1, 0, undefined. 0, undefined. 1 going backwards. Check your answers really quick.